Hello everyone, in this video we are going to solve this question, generate parentheses. This is a recursion problem and the statement says this: given an n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. And this is the example number 1. For n equals to 3, we have these valid combinations of well-formed parentheses. Okay, so we cannot have something like this. We cannot have something like this. Okay, and we can, this is an invalid parenthesis, invalid well-formed parenthesis. Okay, so let's try all the possible combinations. So here we are going to have some keys to know when we can have a valid parenthesis. Okay, so if the number of open brackets is less than n, less than equals to n, that means that we can, no, it's less than n, that means that we can add a new one open bracket. Okay, a new open bracket. New number of open bracket is less than n, we can add a new open bracket. And why this condition? Okay, because if we have the same number of open bracket equals to n, we're going to have something like this. Imagine that n is equals to 3, we're going to have this, and we are going to add a new one, and it's 4. And from here we never going to find a valid well-formed parenthesis. Okay, so we need to be open bracket less than n, and the same for the number of close brackets. The number of close brackets needs to be less than open. Okay, because for example, if we have something like the first character is this, we never going to have a valid parenthesis, well-formed parenthesis from here. No matter that all these are well-formed, we never going to have a valid entire well-formed. Okay, or imagine that we have something like this. Okay, and we add a new one, and we add a new one like this: 3 opens and 4 close. We're never going to have a valid from here. Okay, so that's the reason that we need to be close brackets less than open. Okay, and what is the base case? Okay, the base case for this is when open plus close is equals to n cross 2. That means that we have the half open and the half close, and with these conditions we are going to generate all the valid brackets. So once we reach this condition, we are going to know that is a valid well-formed parenthesis. Okay, so that's the basic idea for this question. So let's create the vector ans. Okay, and I'm going to create a function here. This is going to return me also a vector. No, I think this is not. this is just going to, I'm going to make a void function because I'm not to return anything here. So I'm going to call it f. I'm going to pass this ans by reference to avoid make a copy in each call. I'm going to pass n. I'm going to pass the open. I'm going to pass the close brackets, and I'm going to also pass the string. The string is going to be the well-formed parentheses that we are forming in each call, okay? And we're going to add this s to ans when we find a valid parenthesis, okay? So let's put the base case here. So if open plus close is equals to n cross 2, then I'm going to add whatever I have in s, because as I said, with these conditions we are going to generate just valid parentheses, okay? So, and I'm going to return. So here I'm going to ask if open is less than n, okay? Then I'm going to make a new call. I'm going to pass n, ans and n. I'm going to pass open plus 1. I'm going to pass close, and I'm going to pass the string s concatenate with an open bracket, okay? And then the next condition, if close is less than open, then I'm going to call this function with a close plus 1, and I'm going to pass the close bracket, okay? And I think this all for this question. This is very simple. So let's call the function here. I'm going to call f. I'm going to pass ans, n. I'm going to pass 0. I'm going to pass 0 for open and close, and I'm going to pass an empty string. So I'm going to return ans. So at the end of this recursion, my function is going to update my ans, and we're going to return that ans, okay? So let's run the code. Ans here. I have a typo here. This is a string vector, okay? Because we declare this vector as a string, we need to pass this as a string. And as you can see, we have accepted for these examples. Let's submit the code. And yeah, we have a very good solution, okay? We have a very good time, and we have a very good memory, okay? So basically this is all for this question. This is a very easy question. So if you know, this is the same technique that I have been using in the other videos. Take or not take. The not take is changed to the close bracket, but is the main idea, okay? So this technique is really useful to solve many questions of recursion, okay? So I hope you enjoyed this video, and see you in the next.